just terms that I don't want to forget to pass along to you guys. I'll kind of go through these as we go through, and I've got my brain on a piece of paper over here. So again, going through my experience was not through the military, and I'll be straight up front with you. However, I did learn the MGRS map reading, land navigation, and all of that initially whenever I was younger. So what we need to do is, you know, a lot of us have land nav experience through the military, and we use NGRS in that process, right? But what we're trying to do, you know, especially with SARTAC, dealing with, you know, a lot of civilian organizations, whether it's Red Cross, whether it's search and rescue, whatever the case may be, people don't talk MGRS. Okay, they don't give a 6 or an 8 digit coordinate and say go find it, right? And so if you told them a 6 or an 8 digit coordinate, they're going to look at you like you're crazy. Okay. The other thing about it is MGRS uses a 1 to 25,000 scale map. Okay, so for our purposes, 1 to 25,000 scale map is not easy to come by. Okay, the ability for you to pull it up online, print it off, or take it somewhere and have a full-size map printed off, it's just really not there. Okay, they're used by the military. The military has money. They, you know, you use them all the time. That's how they're taught. That's their tool. Okay. Interacting with folks on the civilian side, we've got to be able to take our basic land nav knowledge, okay, and use that in a UTM, okay, which is the Universal Transverse Mercator. What is it? Universal Transverse Mercator. I get tongue-tied. But that's what it stands for. But that's what everybody in the world really uses, especially when you start talking about USGS, okay, the U.S. Geological Society, or U.S. Geological Survey. So they make these maps in 1 in 24,000 scale, and they're available to the public. You can buy them from them if you want to. They're 15 to 20 bucks, depending on what you get, what area you get. But you can download it on your computer, take it to a print shop, have it printed off. You can print it from your computer. You know, you just kind of have to play with it a little bit to make sure it's to scale. But the thing is, the accessibility of the maps, the interaction with folks that are not accustomed to military grid systems, and just the ability to kind of talk to other folks, lay these things out where folks understand. That's the big reason why we're not using NGRS. Okay, so a lot of the principles are going to be the same, but your grid coordinates and things will definitely look a lot different. Okay, some of these, like I said, some of these other words we'll get into. These were just sort of things that helped me learn as I was going through this as a kid. And I can remember, you know, there were words that just kind of stuck. Okay, so hopefully they help you, and if they don't, then you don't have to take any of those words away with you. So the first thing we're going to do, we're going to talk about maps, and we're going to talk about topography. Okay. Got some handouts here.
Give y'all some useful information on these maps too. Military versus a civilian map.
Pass those around that
Civilian maps aren't near as accurate as a military map, for one.
Pass those around.
Two, there's a lot of things on military maps that will not be on a civilian map. Power stations, nukes, things of that effect. So if you're plotting a course, be very aware that you might be walking through the woods and all of a sudden walk up on a military installation, or you might walk up on a nuke or something to that effect. You might have to replan your route according to restricted zones and stuff to that effect.
Yeah, I mean, what you're going to find things plotted on these maps that, there's you'll see like the one that we printed off for today's exercise. You're going to see spots that say gravel pit. You're going to see markers for churches and things like that. So you're not going to see, a lot of the things that Rose was talking about. So what I've handed you here is a lot more information than you're probably ever going to need. Okay. A lot of these symbols and things we're not going to use today. I wanted to get them in your hands so that you have them. You can look back for reference and say, hey, what is this on the map? Okay. So again, like Rojo pointed out, they're a little bit different than the military maps. So some of the symbols are a little bit different, and so hopefully you can familiarize yourself with those. All right. In addition to the field exercise here in a little bit, we are going to have a bit of a written quiz, and we're going to break you guys up into teams, and so everybody can kind of help each other get that knocked out. See, we'll go ahead and hand out the map real fast. So this is a practice map. If you want to start that around.
Triple north method?
Triple north.
Yeah, all your equipment has to be orientated north before you start.
Yeah.
Maps north, compasses north, protractors north.
Hell's Kitchen.
Huh?
Hell's Kitchen.
Well, there's a lot of people will take a protractor and they'll turn them 90 degrees off.
Yeah. I'm saying Hell's Kitchen.
Yeah, now.
Does anyone need a pencil?
Yeah.
Sure.
What I always do is I'll take and I'll get my compass and I'll say, here's north. My map is north, my protractor is at 0 or north, and then I start working from there. Mm-hmm. And I will physically orientate myself north. I know I am north.
Yeah.
So that everything's good. And a lot of people won't. They'll be facing south with their map facing south and all their stuff, and they're like, and they get all out of whack because, wait a minute, my needle's pointing north this way, and it just confuses them. But if they physically orientate north with everything orientated north, it helps them a lot better.
Can you pass those pencils around?
Yes.
I'm running 3 more around. Who needs one?
Way around. I like that kind. Hey, operators, this may do better for what we're fixing to do.
Thank you.
Oh, I remember these.
Thank you, sir. Yep.
Hey, Rusty.
I remember these.
Oh, you're still using charcoal and a stick?
Got you.
Teacher.
Damn, I thought I was finished.
Oh, this is got a
You guys will see that I gave you guys some frou-frou colored pencils because I want to get them back. I didn't figure anybody would walk off with.
I'm keeping mine.
It's like a
yellow number 2.
I got a nice blue one.
Indian giver.
I'm keeping mine.
Yeah, I figured you would.
Oh, crap.
All right, so real quick about the map. So the main thing that the main things that we're going to use are if you were to see something like this on a map, what does that represent?
Hill.
Top of a hill. Okay. So now if you see something that kind of looks like this, what do you see in there?
Elevation step downs.
Okay, elevation
Saddle.
step downs. What is this feature called?
Saddle.
Mountain.
Okay, so this
Contour line?
be like a ridge. Okay, so ridge is just like a series of hills, and then in between you got the saddles, and then you got your spurs that come off here, and then in between the spurs is where you have your draws. Okay. Other things to look at, which we'll cover this on the map here in a second, is see elevation lines that kind of do this, and then all of a sudden they start to get really close.
Get steeper.
Okay, what do we seeing? We're coming down off the side of a hill. We could be looking at possibly a shear face, and in one of these spots. Okay, so why is it important to understand? Let's say I'm on this hilltop, and I need to get right here. What's the quickest way to get there? I mean, like
Just a straight line.
straight line, right?
Jump off the cliff.
So if I go off a straight line, what am I likely to encounter?
What are you gonna what?
What am I likely to encounter?
Cliff. A bluff.
I'm gonna hit something that's pretty steep.
Yeah.
More than likely.
Yeah.
Right? Now, let's say these continue on out here. Now, if we're actually gonna hike this out, where am I gonna go?
Make a waypoint.
Flat land.
Okay. When we go over here, it's gonna be farther for sure.
Yeah.
But I'm gonna try to come in here and then make my way in, right? So the land features absolutely play a critical part in where am I going and how am I gonna get there. I can absolutely get there going straight, right? May not be safe, and I may not be experienced enough or in shape enough to make that happen, okay? So understanding how you avoid the terrain obstacles is kind of key with this, okay? Real quick, let's go over a couple things on the map. So declination. Who wants to describe what declination is? Okay, very good. So it's the difference between magnetic north and true north. So if you set your compass down on the map, right? Where is the needle on your compass? Where's it pointing?
Magnetic.
Magnetic north. Okay, so 30-second science class here. The crust of the Earth is kind of sitting on a large pool of magma, right? It shifts, it varies, very minimally. But if you're talking about, long distances, one point on the Earth may move over 15 years. It may move, 3 degrees. So that declination is updated every couple of decades, and then you have to pay attention to that on these maps. Okay, so what we'll see here, what's the declination on this map? 17 degrees. So how do I know how to adjust my compass?
You take whatever your azimuth is and add or subtract your 17 degrees.
Okay. So if my magnetic is to the left, then I'm going to add those degrees. Okay, whatever that declination is. If I'm to the right, then I'm going to subtract that declination. So LARS is an acronym that I was taught years ago. Left add, right subtract. So if you're
on the positive side, 1 through 20, you subtract. If you're up in the 300s, you
so if my true north is here and my magnetic north is to the right, then I'm going to subtract on my compass those degrees, that declination. So in this case, it would be 17 degrees. So whenever I'm looking at my compass, it's not actually, my compass isn't actually pointing, my compass will be pointing about 17 degrees off of where my travel path is, okay? But it's easy to work with. It sounds a lot more complicated than what it is, okay? Rojo hit the nail on the head. It's just a matter of kind of memorizing a couple of these little tricks, and you can take a compass and a map and a string or a ruler, something, and bail yourself out of just about anywhere, okay? So the declination, like I said, the easiest way I remembered it was LARS. If my magnetic north is to the left, then I add the declination. If it's to the right, then I subtract. Okay. So in this case, where's my magnetic north?
To the right.
To the right.
17 degrees to the right.
So what I'm going to do is I'm going to subtract that 17 degrees off of true north, which is it's 0, right? So 360 essentially on your dial of your compass, and you're going to back that up 17 degrees. Okay, and when you do that, then your compass and your map are both pointing oriented north. Okay, they're aligned. All right. If you don't do that, what ends up happening, obviously, is you walk 17 degrees off in the wrong direction.
You might be 4 miles off the target.
So I'll leave you guys with this little tidbit of information as well. If I'm starting here, and let's say this is 1,000 meters, and I'm supposed to be here, and let's say I'm 10 degrees off, okay? That distance right here, I walk 1,000 meters, supposed to be here, but instead I walk 1,000 meters and I end up here. In 1,000 meters, you end up being off about 17 meters. Okay? Now,
It's what, 100 yards?
17 meters.
17 meters. Yeah, that's
That's about
3 meters is 10 feet.
No, I'm sorry, I told you wrong. I told you 170 meters. I'm sorry.
170.
Yeah.
170 meters. Sorry.
yards off.
For every 1 degree is about 17 meters.
Yes.
Okay, that's the rule of thumb. So 170 meters difference. Okay, that will really complicate things for you, especially in terrain like this. You're not really going to find where you're at. You're not going to know what to do next. Okay. Now, how do we determine if we're going up in elevation or if we're going down in elevation based on the map?
you look at your ridges.
Okay, what do the ridges tell us?
Moving forward and you're going up.
Well, you'll have your you should have your elevation numbers on it, whether they're going up or down.
Absolutely. So if you guys will take a look on your map, you'll see the contour lines, and you'll see some of them are darker than the other ones. Okay. Basically, what that's going to tell you is that's a major contour line, and then you go to the next major contour line. Determine, did that number go up? Did it go down? So, if we were to look at, let's see, where's a good one?
There you go. There.
What is this map of?
Sap Hill goes up 3 times.
Where you at? Yeah. So, right here in this quadrant here, where Dogman was pointing to, right here where it says Bloods, you see those contour lines, okay? In the middle of that grid, you see 6,400, okay? Now, what you need to do is you'll go to the next grid line and follow it out to the left or the right to find out what that next elevation is, okay? So you got 6,400 in the middle. If I drop down to that next grid line, or to that next major contour line, thank you, and I follow it all the way out to the left, it tells me 6,200. Okay, so I know from one contour line to the next, I dropped 200 feet. Okay, what would be another indication that I'm dropping in elevation?
Big circle around the small circle.
Well, not necessarily. What would be a huge indicator 90% of the time?
Rivers,
water,
streams.
Rivers and streams, okay? Especially around this area, okay? You get down, I mean, we see it here today. I mean, you get down into a draw and there's water, okay? So don't spend too much time take those, little hints and those little triggers and say, well, I know I'm going downhill because there's water at the bottom, right? All right.
Dave?
Yeah.
Now, I was told one time, and it makes sense, that when you find a river, creek, or something, and your contour lines, and I'm seeing on here as well, your contour lines, if you got the creek, contour lines will come in, and that'll also show the direction of the water flow. I don't know if it's true 100% of the time, but it makes sense, because that's why your contour line is going down. So.
Yeah. I would have to tell you, I don't have enough experience in that to know if that's always
really
the case,
don't either,
but it
but I
sounds
was
like
told
it makes
that.
sense.
By a reliable source.
Yeah.